Okay, I think I'm live on Facebook. And I don't know much about streaming on Facebook. I've been streaming on Twitch recently. And I have a lot of things I want to do related to computer programming because computer programming is definitely a big passion of mine. And I've been streaming on Twitch, just trying to build a following on Twitch recently, but I have not really had much success with that. Although I've had some really good chess games. So now I think I'll be able to come back to view the comments. Oh wait. Oh, one comment. Oh, but is that this? Okay. Oh, okay. I guess there's one comment. I think that's an automatic comment. Now, okay, so let's see some stats here. So yeah, I'm connected to Facebook Live right now. Um, and what I'm using OBS Studio on Debian Linux. Debian Linux, which is without a doubt the best operating system in the world as far as I'm concerned. I've used a lot of Linux distros. I have Windows 11 on a different computer. Now, this computer that I'm using right now I use exclusively with Linux. I bought a new laptop to use with Windows 11, but I still love Linux the best. And OBS seems to be running fine. 30 frames per second. My CPU usage is less than 15%, and I've been live for just under 4 minutes. So, here is my desktop background. It's a little bit of a logo that I made, and you can see that it has a checkerboard, and it has a big white circle, the white rose, my name, Chastity White Rose, the vegan virgin. It's kind of a thing I made because I'm an artist, computer programmer, Tetris player, chess player. I do everything. And I've done numerous videos of this, but of course no video is complete without showing off my Tetris game compile, run, my Tetris game Chase Trist that I have, worked for over 2 years on improving. There's a little tile screen, it shows off my Patreon, my email address, all that sort of thing. And this is the Tetris game that I made, and I can play it on Linux or Windows. I tend to do a lot of my streams of it on Windows 11, but the whole game was built on Linux. It uses the SDL library. I have full control up, down, left, right, rotate, swap between two blocks. I've got everything. I mean, this is a complete Tetris game, and I've shown it off a lot because I'm very proud of this game, of course. Because I play basically every Tetris game. I can actually play Tetris quite competitively because I practice a lot. But I also love chess. This is an obvious thing people know about me, and I even started a little project. I haven't gotten very far because I only get 1 day a week usually to work on it. Because between work at Walmart and school, I'm very busy, and so I don't really get much of a chance to really work on things. But I'm going to show you very quickly what I had. And see, the way, even though I have an executable, I always just open terminal and type make, compile, run the whole thing. And here is, what I had. I showed this in a previous stream on Twitch, but people missed it. So, yeah, I was just doing some basic development, trying to make my own chess game, trying to get some basic code running to highlight where a piece can move to. It needs a lot of work. And I realized that I don't have the time or the energy to work more on the chess game. The chess game is actually really hard. What I did, and of course you know, I'm a very slow programmer. I don't it's my hard work and dedication that's allowed me to do as many things as I do with programming. And here is another cool little project that I did. Let's see here. Let's see here. Now, okay, SDL mixer. Okay, that was a special thing. That was with Sun. Now this program here, this was a Powers of Two program that I did. It uses several libraries of SDL, and then it displays the Powers of Two. Now, the Powers of Two are really where my computer programming journey began. The Powers of Two is where it's all at. I'm serious because I was obsessed with math and numbers, and the concept of starting at one, you just keep doubling it, you add it to itself. It was such a simple process. I used to do this on paper. But then I thought, if I could get a computer to do it, that would be awesome. And I actually wrote my own Powers of Two program to generate the Powers of Two, you know. And this is like a video that scrolls the Powers of Two, and it's very beautiful. It's really amazing looking, of course. Um, but and it keeps going. It doesn't really have. There is a limit to it, just theoretically, but it goes on. But you get the idea, and that program is actually quite complicated because if you take a look at the source, there's a lot that has to be done because there's all the stuff about the font and loading the SDL stuff, making sure error checking. There is a whole lot. Like that is actually a very big source file, although it's still contained in one file technically. Oh no, there's more than one. I have like probably about 10 kilobytes of code between all those files. However, that's the SDL graphical animated version. But if you want to see a Powers of Two program written in plain C, here it is. The Powers of Two. There's the compile command. It's actually very, very small if you think about it. All we're doing is we have X, Y, and Z variables. We're defining an array of length 1000, and we're initializing that with all zeros except the bottom one that is 1, and then it literally adds each digit to itself, and if it's greater than 9, then it will make a carry variable and then add it to the next digit. So literally addition. Addition, the simplest of all mathematical operations. This is actually extremely cool. And if you, for example, if I go into this place, just make, do you see that? Did you see what happened there? Like I type make, it compiles and runs the program that fast. That is how fast this computer is. And there's a lot here. I have to scroll all the way up, but you see it compiling, and then it runs the program. It generates all these Powers of Two. That's the power. This is a very fast computer, and generating these Powers of Two with my small C program is not very CPU intensive. I've done it on much weaker computers, but the source of this is 558 bytes of the entire source code, and there's a make file. That's the kind of thing. Now, I actually have in mind what I liked about the Powers of Two project. There's actually an entire GitHub repository of that. Let's see, do I have any commenters? No, nobody cares about my live programming video because people aren't smart enough to appreciate it. Okay. Yep. Okay, nothing new. But what I want to show you is I have a little project in mind. A little project in mind that something small, something that's manageable that I should be able to accomplish with programming in less than an hour. See, I have, my Tetris game is kind of the base of a lot of things, obviously. It's just very cool, it's very graphical, has all that. Now, but here's what I need. Now, okay, not gonna lie, this is cool to look at. This is very cool, Chastris. But what I was thinking is I need a little bit of an animation, a little animation that I can use on my videos as an intro video and my live streams. I want to have like a little intro. Kind of like how Finster has a nice little intro. Let me check on OBS. Yeah, okay, that's cool. I want to have like a little bit of an intro. So what I'm going to do, I'm gonna look at some of my projects. See, I have let's see. I had a little bit of a project here. Let me try this one. Let's see here. This was light graphics binary text, and you'll notice it says LGBT, but I use that acronym for light graphics binary text, um, and it's the same font used in Chastris, but also, of course, LGBT stands for lesbian, gay, bisexual, and transgender, of course. Um, but I just used that same acronym. That was a joke, a little joke project I did there. Now, let's see here. SDL chased bitmap. Now, here, yeah, okay, here's the thing. Chastity progress flag BMP. Now, this is interesting because you'll see if I compile and run this, notice that it loads this progress flag. It just totally loads this progress flag, and this is a really nice image. This image is one of my favorite because the progress flag, you can look up the progress flag on Google and you will find it's a symbol. Like it includes all the minorities and stuff, including intersex. I want to point that out here. The yellow triangle with the purple circle, that's the intersex part of the flag. Um, but yeah, this is my own custom color design. So it doesn't match the standard colors exactly, but it's close enough everybody can see the progress flag. So let's see here. Let's take a look at this. So here we have some images. So here is a bitmap. Oh wait, I did not. Okay, it's loading the entire thing in GIMP. That wasn't what I meant to do. I want to, let's see, I want to open this in the image viewer here. So here we have, we have the progress flag BMP, we have the progress flag PNG, and we have whatever that is. Whatever kind of crazy, what kind of image is this? I made a I made a little test image. I wonder what I was doing with this. Let's see, but it's hard to see. To be able to actually view the image, let's look. I think I was testing different types of images. So let's look at this. Let's zoom in on this as big as it goes. Let's see. Forgot. How do I zoom in? I don't use GIMP very often. I use it to edit pixels of an image if I need to, but I don't really use it often. But this is basically Photoshop for Linux. That's basically what GIMP is. So let's see here. Where do I zoom? Okay, zoom. Okay, let's zoom in. Okay, zoom in is plus. So it doesn't zoom in any bigger than that. That's weird. It why isn't it? Okay, wait. Okay. Oh, there it is. Okay. So this is the tiny image. Now this is a 4 by 4 image. What was I doing with this? What was I even doing? I don't even know why I made this image. It's actually really cool, of course, because here there's red, green, blue, and white. I was doing something with it, but I don't know what I was doing. I was probably just creating an image to test the program. So let's see here. Let's take a look at this. So now this is a still chased bitmap. This header contains utility functions for testing or manipulating bitmaps stored as SDL surfaces. Okay. This function tests all the pixel values and is frequently edited as I see fit. It is of no use unless the past bitmap is of SDL pixel format BGR832. Okay. Yeah, so there's a specific format that I need my images to be in. But that it prints the value of every single pixel. And now this function removes the alpha value of the bitmap, which is expected. Okay, let's see. I understand this. Let's see here. Okay, yeah. So that simply, it gets rid of the alpha value just to make sure, because I have certain bitmap copy to surface. This is a useless function, but it shows how STL blisters probably works. It is, for example, never to be used unless testing. So you see here, some of my projects, like this is where you actually access the pixel pointer directly. So here we have a surface of bitmap, and we have an STL surface. And what we're doing is we're setting the one that's just called surface equal to the bitmap pixels here. And the idea is it copies absolutely every single bitmap into, every single bitmap a pixel into the other bitmap. Now, this is not something that you typically do in modern SDL. Technically, this is SDL2, so it's still valid. Let's see. This is my implementation of scalable. It only works in my image viewer because it creates multiplied by the global scale value of the image. Okay. Yeah, so I had some stuff going on here. And what you'll notice if we go to the main source file, this one, there's a lot of things that my programs do. There's a lot of boilerplate code here. Processes command line arguments, which aren't really used here. Actually, they are, looks like. Okay, so let's see here. So it tries to use SDL load BMP. That's what it does. It tries to load that bitmap file, which is cool. And now SDL by default only has support for loading a plain bitmap file. It can't load PNG, JPEG, GIF, all of that stuff. It can't load that by default. But what this program, this is an example program that I did, is it loads it, and then if the pointer is null, meaning there was a failure loading the image, then it prints a message. SDL could not load temporary image. And this is a temporary image. And then what it does is it takes that bitmap, and bitmap equals SDL convert surface format, and it converts it to this format. And then, so the bitmap temp, if that's null, then the actual bitmap we're going to convert it to equals this. So it's converting it and making a new bitmap. And then if that bitmap is null, then could not load image and print the error message. And then after we're done with that, we free the surface, so we free the temporary bitmap. You have to free your memory in the C programming language, or it just doesn't work. And then what it does is then in case there is any alpha in an image, it will just call that function I showed earlier to strip all of it out. So here's the thing, is that it does that, it loads an image, it converts to the right format, and then it actually copies it to the surface using my own routine, which is not necessary, of course. But it was the way that I did it. It was just the way I did it because there's actually a faster way. And then it saves. This is set to 0, but if this was set to 1, it would save a surface that's an output.bmp. In fact, let me show. So notice that in this directory, there is no output.bmp. So let's change this 0 to a 1. Also notice I do my programming in black and white. That's because it's easy for me to read, although sometimes I need syntax highlighting in certain cases. So let's go here and let's do make. Now, okay, there's our progress flag. It looks very beautiful. And I'm going to be using this progress flag as part of an image to, I want to make a special logo or an intro. So I'm going to be using this. And there's another one I could use as well. But the progress flag just communicates a message, so it's nice. So I'm gonna press escape and exit the program. Notice that it says it's opening that file name, and it did. But now notice that an output.bmp file exists here. Well, that's because after it displayed that image to the after it displayed that image, then it saved it to a file. And that's a nice image. It's a really nice image. Let's look at the properties. That image size is 1920 by 780 pixels. Yeah, okay. That's cool. And let's look at this source here. Let's change this back to a 0 because we don't need to write that out every single time. Now this, okay, actually this now copy to surface scaled, um, that's not actually used in this particular program necessarily. We're just using SDL Blitz surface. But there's a reason for doing things with this. Yeah, I'm trying to think of a way to communicate this. There's a way I want to be able to communicate this because I need to make a small program. Yeah, SDL chase bitmap. It's a nice. It loads an image and displays it. That's literally it's actually an image viewer. However, it can only load BMP files. Now, I remember it's been a really long time since I made this project. Let's see here. Let's see. Do I have any comments on my stream? No, I have no comments on my stream. Nobody cares about my programming except me, of course. So, I'm going to use the restroom. Okay, let's see here. And let's see. I know what I'm going to do. I'm just going to display this progress flag here and use the restroom. And when I come back, I'm going to explain my other project. Okay, let's see how everything's going here. Yep. All right. So yeah, OBS is still going strong, looks like. So now I'm going to explain my next. I after I did the STL Chase bitmap, I used some of that code to make a new project because what I do is notice there's all these projects. A lot of these projects do little to nothing. They're always a base. For example, this SDL music project, which I can't, for copyright reasons, I can't really do because it. I have a program that will play these songs that I downloaded from OC Remix, which is so cool. But you know how when you social media, all the stupid copyright stuff. But yeah, that was a project for music. So now, and oh, I remember this. This was very interesting. I had a, oh yeah, this was cool because this was a project that uses SDL. Yeah, it did some really fancy stuff. I have so much old code that I forgot I even had. Let me take a look at this one because this actually had the code to draw regular polygons. And I later incorporated this into Chase, but it has a polygon structure, and it does all this fancy stuff to get the vertices and then sets up the vertices structure, um, you know, the way SDL expects. But this doesn't work for surfaces. It only works for the SDL renderer with SDL render geometry. So you kind of are forced to use the renderer instead of the surface. There's more than one way to do things, and I like it that way. I hope they keep it that way in all future versions of SDL, so that you can either just update the Windows surface and that kind of thing, or you can draw it to a renderer. There's more than one way. But yeah, so I mean that works, and so this one is set up the right data, and it uses a series of triangles to to draw the to draw a star. It actually draws a five-pointed star. Let's see here. Actually, let me show this. Okay. What I'm going to do is I'm just going to show this project. So right now you see it has the text and it has the star, but the star is not doing anything. But if I uncomment this code here, wait, not this one. It was the other one, the rotating code. So here is, instead of, okay, let's just copy what's in that comment out here. And then when I recompile and run it, notice how the star spins. Now the star spins. That's because I actually have all the code to draw regular polygons using a whole bunch of triangles. It draws 5 white triangles overlapping each other to create that star. And it can spin. So that's actually a very, very cool thing. And has the text cool to describe it. So I love that. And in fact, I mean, there's no reason not to just leave it that way. Well, I mean, why not? Okay, so anyway, but let's see here. Okay, so, but I'm actually trying to do something much, much simpler for this. Let's see here. Oh, cross-post your live video to pages so more people can watch. Oh, this has a lot of options. I don't really know. We don't have any. Okay, I'll work on that later. I'll work on that later. Yeah, anyway. So, but I'm actually looking for something very simple. Now, it's hard to describe what I want to do. It's very hard. But let's see here. I have some OpenGL. Let's see here. Let's look at this. Okay, now this, you see this here is an OpenGL example. It's very cool. I mean, it works great. But yeah, so this is a compile and run. This is an OpenGL example. And you see the way the checkerboard there interacts with, you know, the spinning shape there, and it looks really beautiful too. That's kind of what I'm going for, but that the way it does it is a little bit complicated. So this is OpenGL. It uses OpenGL with SDL, but it's really complicated. It uses some old legacy, some very old legacy OpenGL. And the way it does the XOR, it uses the GL logic op, GL XOR. And the thing is, if I don't have this thing enabled, if I don't enable that, then it just draws the checkerboard, then draws the red 6-pointed star, you know. But the XOR drawing mode, that's something that exists in OpenGL that is actually really cool, you know. So let's put that back the way it was. And so the thing is, I want something similar to this, but with the progress flag, and it's going to be a little bit complicated here. So I'm going to attempt to do something. So I'm not going to be using OpenGL. I'm going to be doing something a little bit different here. Let's see. Now let me look at my SDL chased image. Let's see. Now here's SDL image examples. Oh, I don't have any examples. That's funny. Okay, STL chased image. Now this one is a program. Let's compile and run this. Let's see what we've got here. Now this one is cool because it displays text that STL chased image written by Chastity White Rose. Enter file as command line to display it. Example, progress flag sample image designed by Chastity after looking at similar images. So, here's what we're going to do. We're going to literally copy and paste this output command here, and we're going to run this program. We're going to totally run it. Okay, so we're going to load that image. Yeah, and there it is. There is the progress flag. It's literally an image loader. So if you just run main without entering an image on the command line, it displays the message telling you how to use it. But if you actually do enter that command, it will load that file. And let's see here. Notice that it also displays the bitmap width and height. And the original, I created that image in Inkscape, and I made it, that is high definition image resolution, 1920 by 1080. And in fact, it's the same resolution I'm using right now for this stream, and I hope the stream is going well. Okay, so let's see here. So let's see now. Let's look at, there's other things. Now, there's the font file. The font file that has the characters. I use that in all my games. Let's go to the bitmap. Now, here is the progress flag image. This is the progress flag image. It's actually super cool. Yeah, 1920 by 1080 pixels. So the progress flag image is present. It exists here. It's actually a really, really cool thing. Yeah, I just love looking at that image. But I want to expand. I totally want to expand. Let's see here. Let's look at the source code. Now, this is STL chase font surface. Okay, yes. So this uses the surface code. Because this one, it doesn't use a render. It uses the surface, and it does some fancy stuff where it converts the surface to the screen. Very interesting. It does that. It converts to the same. It does it differently. Some of my other programs do it differently, but this works. Let's see here. Yeah, so this is some old code, but it doesn't mean it's invalid. It works for what it does. And this uses blitzscale to set up rectangles for each character. This is the font drawing stuff for drawing characters of text from the source image. And it works, but in order for it to work, this one, yeah, this does direct pixel access. I have some direct pixel access in here, and it's very amazing. It's very amazing here. So let's take a look. That's just for the font. Now, so it uses the font, but it looks like the only other source file. Oh, also, look at this. This is a Windows batch script that when I had W64 DevKit installed on this computer on Windows 10, I had a Windows 10. I deleted the whole thing because it was corrupting my bootloader, and I had to reinstall Linux. It was so sad. But I still have the script here. It's very useful because I referenced it when making other compiling scripts. But this is for Windows, but I always keep it in my Linux source tree because, after all, my Linux source is the original source. So here we have that image. Besides the font library that I wrote for STL surfaces, everything else is in here. Okay, STL chased image. This program is an image viewer that makes use of STL image to load and save PNG files. Okay, so it loads all the standard libraries. It loads STL. It also loads STL image. It includes all those header files. That's a lot to include, actually. We have the file name and the text strings. Here's the thing is, I know the C programming language really well. Not so good with C++, but I know C style strings. I know a lot of stuff here. So, it initializes the video, and then it tries to initialize PNG support. That's what it does. I mean, PNG is the real best still image format. It like widely supported, even though some may actually have better compression. And then it processes the command line arguments, and if arg count is greater than 1, then it's going to try to string copy that file name from argv1, the first argument, and file it into file name. And then, and this was just an example when I was testing it before using command line arguments. So yeah, so that then it loads that image. So then it does the same thing as SDL bitmap, that project. So it does the same exact process. You can see how the code was copied. So if bitmap temp equals null, then that's an error. And then it converts that surface into this format. It totally does that. So it converts that into that format, and then it frees the temporary service. I said service. I meant surface. Okay, so let's see here. And then it fills the entire rectangle of the bitmap with okay, so so this one, if it can't load something, if it's let's see here. Yeah, if there's no arguments, then no bitmap was given as argument attempting to create blank image. So it decides to create a bitmap that's create red, green, blue surface with format, and then it fills that with black. Alpha is FF, obviously. But then it's all zeros, red, green, blue. So it sets a 32-bit with this format. It sets a bitmap. It creates a new empty bitmap filled with entirely black, and then instead of loading the image loaded, because there is no image in this case, it simply creates an empty black image surface, and then in either case, if that bitmap is null, then print the error. But then it gets the width and the height of the bitmap. And then here's the beauty of it. It accesses the elements of that pointer, struct pointer, and it gets the width and height, and it displays what the width and height were. Yeah, it's cool. So you'll see that whenever the program was run here, that's what it does. We compile, run, it displays that, but it always shows the bitmap was loaded and the bitmap width and height, and it displays information about the font. So that's what it does, of course. But here, what we want to do is, but then of course it gets the surface. So we have bitmap be the surface that we create initially by loading or creating it on the fly. And then we have surface equals get window surface here. So it gets whatever the surface for the window that was created is. And notice that it creates the window based on the width and height attributes of the bitmap. So it first gets whatever the image is going to be, and then it creates the window based on that, which is very interesting. Now, what's strange about it is, actually, that's a little bit weird. I'm trying to see here. Okay, let me test something. Let me go back, because it is trying to load whatever the size of the image is. It tries to create a window of that size, but because of the title bar, like all that stuff, it doesn't fully succeed here. But so here's the thing. I want to do something here. I really want to do something cool. Um, yeah, and it does all, it blitzes the surface, copies that to the surface. Yeah, I'm seeing how it works, and then this, it actually can save as a PNG file. That part of the reason I went with use the STL image library is not only can it load PNGs, but can also save PNGs. And if you need to save, you know, tens of thousands of image files, which I've done for some of my animations, you have to have PNG because they're a lot smaller than BMP. Okay, and then at the very end, it frees all the memory used with all of that stuff. It frees the surface for the font, and the bitmap destroys the window, quits the image library and the main SDL library. It does all of that. So here's the thing. I'm going to exit out of here because that project works. It works flawlessly, and I absolutely hate to mess things with things that work. That's why I have so many projects. I have so many programming projects because, like, hey, this project just one thing, and it does it really well. So let's see here. Let's go to Chastity. Okay, to Chastity programming. So let's go here. And wait, no, not the programming. I meant to go to my art. Okay, big USB backup. We're going to go to the Inkscape artist. Because I have, like I did, well, actually, let me first show you. I have tons. I have art for sale on websites. Not that anybody ever buys my stuff, but I have it out there. Um, so I have all these images. Like I have a big old art show. I have a whole lot of beautiful images that I've designed in Inkscape. I have all of these beautiful pictures here. And I've always made sure I back up these files. These are the PNG files that can be uploaded to any website. And I could theoretically load any of them. There's the Midnight Rainbow used in part 4 of my story for my book, A Chandler's Honesty, A Horse in the Night. That one is a nice, the Midnight Rainbow. Hey, there's the cute 8th note. Yeah. Yep, there's the night and day skies. I have some very, very beautiful pictures. Like, I did a lot of art. I did tons and tons of art. Man, there's the rainbow. There's a lot of... Notice that there's a theme in all of my art. Notice that in my art, there's always a theme of it's either black and white or it's so colorful that it has pretty much an entire rainbow. You know, I have a theme with the colors. I have my own color coordination. There it is. There's the 6-stripe hexagram, black and white, and rainbow. It's one of the best pictures I've ever done. I forgot how I even did something so awesome, but I remember that I did it. It was actually pretty cool. Um, but yeah, so there's a lot of art there. So much art. Oh, there's the Eye of Eternity. And I even published this art in books. The reason I have all these files organized the way I do is precisely because they all were going on certain pages and everything was done a very specific way. But besides the PNG images, and let's see how many there are. Besides the fact that there are 160 items there, there's also the original SVG files. So I have all of the SVG files. So for example, just for the sake of an example, let's go to the Happy Pumpkin. And I need to load this in Inkscape. Now Inkscape is the program that this Happy Pumpkin was created in. And I haven't used Inkscape in a long time, but so if you look at this, okay, there's the whole thing as a group. Let's undo, and then we're going to ungroup, and now you see they're highlighted separately. So yeah, it's actually really cool. So check this out. That is 2 circles. Like everything there, these are plain geometric shapes. So we have a white circle inside of a black circle. We have, yeah, and I can further ungroup the, actually, let's ungroup everything. Let's just totally ungroup it. So see everything, these are circled. Actually, the snapping is actually, okay, because I installed this program after installing Linux, and let's see here. Where's the snap controls? Where, okay, let's see here. Okay, yeah, the snapping, let's see here. Because the defaults for the snapping, I don't know. Yeah, where are they? Okay, let's see here. Oh, okay, yeah, so here is, okay, so yeah, so to enable or disable snapping. So now with, see, if the snapping is on, then it moves it like that, according to other objects, which is nice. But when the snapping is off, it just lets me free move these anywhere I want. So you see, these are circles. We had white circles centered in black circles, and this is a half black circle. This was the mouth of the pumpkin. It's actually cool. And then this is just the, actually, check this out. This is a rectangle that was right here, and then each of these are two orange circles next to each other. They're just basic, circles, half circles, a rectangle, a long orange rectangle, a little green rectangle to be the stem. And of course, now it looks absolutely nothing like the original, but no problem. We're just going to close without saving, and then when we open it again, it's going to load it again. It's going to look the way it did. So there's the happy pumpkin. It's actually really cool. So I'm an artist. I have not done my Inkscape art for a long time, and part of the reason for that is because even though I miss it, I don't make any money off of my art. It's sad. Like, I've really tried to promote it, but I have, all my time now is work in school, so my art has fallen by the wayside. But that's not to say I haven't done some new art occasionally. So that is all before October 2018. And then after, there have been a few. I have done a few because it's been very, let's see now. That was the white rose image, and it tells where I got the original white rose. I didn't make that rose. I got that off of Open Clip Art, so that's royalty-free clip art. But if you look at this, here I have the SVG and PNG files together. I have them both together, so that's cool. So let's take a look at some of these files. So, wonder why is that says old? Oh yeah, that's the old style. Okay, there's the progress flag. There's the SVG file. There's a PNG and SVG of everything. So there's the progress flag. Okay, there's the standard definition progress flag. I like that. And then here is the chassis progress flag checkered. It's cool, but it doesn't see what I want to be able to do with this. I made a little bit of an outline of what kind of something I had in mind for this. So, and there's my little logo I made. And then there's the same thing, but bigger. It's like, oh, Greg, here's Bailey's a bit bigger, It's really cool. But let's look in Inkscape, because knowing the composition of the way this originally done is interesting information. So here we have, let's see. So let's look at, wait a minute. Okay, yeah, so there's more than one here. This one is 1920 by 1080. Okay, right. So here we have, okay, so I'm going to rename this because I want the name to show which one it is. 1920 by 1080. So there we have it. So I've made that one reflect the size that it is. Yeah, so that's important. So if we check the properties, we'll see that yes, that is 12. That one is 1280 by 720. But then the other one, the other progress flag is this size. And I need to make backups of all these files again because the last time I made serious backup was December 17th. It's been a while. I do regular USB backups and online backups of all my files because this is important stuff. So, but let's look at the Inkscape file, the SVG, the Scalable Vector Graphics file. Let's look at this. So, notice we have some of this shape here. We have it off to the side here. Yeah, everything is grouped as one. Oh, that's interesting. Okay, let's look at. Oh, what's. Oh, wait a minute. Oh, wait. Okay, let me. Okay, yeah, I don't know. Okay, let me revert. Okay, yeah. Okay, let me. Yeah. So here's the thing: is I've forgotten. Oh, okay. Grayscale. That shows the grayscale mode of it. Okay. Yeah. Let's see. I want color. Okay. Yeah. Okay. So here, what we have is we have this. We're going to. Okay, how do I zoom? Okay, so zoom to 1:1, zoom to drawing, zoom to, okay, so let's go here. So here we have several different images. So notice that, yeah, there's that. Yeah, so here's the page view. Okay, yeah. Zoom page width, and page. Okay. So here is where, because when I press 4, it zooms to drawing. So you can zoom to the selection. We can, okay, yeah, everything's selected right there. Yeah, okay, that's weird. But if we zoom, notice here, this is the one that I designed. And part of it's, you don't need to see all of that. That's off to the side of the actual frame of the image. But here you'll see these two here are progress flag images that I downloaded. I downloaded these images and imported them into Inkscape so that I could look at the progress flag while I designed my own version of it. That's what I did. And as you see, the colors are actually pretty close. They're pretty close, but I personally think I did better. My colors are more extreme. They're much more extreme than the originals because those, they were probably JPEGs that, they got compressed and they didn't look quite as fine. So let's see here. So here's mine. That's what it looks like. And then if we go here, this one, I mean, all the progress flags look good. They're so colorful. But yeah, it's actually really awesome. So yeah, and since just to show you every single part, we're just gonna ungroup everything, and I'm going to show you each little thing of this, each little part of this. There's a rectangle. Here's an orange rectangle, a yellow rectangle, a green rectangle, a blue rectangle, the purple rectangle, and then yeah, here are the chevrons. There's our purple circle. Here's the yellow circle that was on top of it. Here is the yellow triangle. Here is the white chevron, the magenta chevron, the cyan chevron, the brown chevron. Getting the right shade of brown I worked on for a while. The black chevron. And so now it looks like just complete chaos, obviously. But that was all together. And if we revert the file, revert all the changes, of course there's backups elsewhere too, then we see it back in one piece. So this is the editable file. and of it, and it was originally designed as yeah, see, it was designed with standard definition, but you can scale things. You can totally scale things to see image size. Yeah, interesting page. So see, so if we do 1080, you see how it automatically scales it. So that's how I can make any size image. I made the original one here, and I can scale it to any dimension. Absolutely. So there it is. Just see a little behind the scenes look at my art, how some of that works. Okay, let's see here. How's everything going? Um, yeah, nobody's commenting, but that's all right. That gives me better concentration. So now we know where the image came from. It was designed in Inkscape. But I'm going to use the restroom, and when I come back, I'm going to actually I'm going to display the houndstooth image. And while I use the restroom, and when I come back from the restroom, I'm gonna I'm gonna try to proceed with a little bit of a plan that I have. Okay, yeah, there's the houndstooth pattern. It's actually pretty cool. A lot of neat stuff. Now, so here's what I'm wanting to do. So here is the checker written, you know, black checkerboard on top of the progress flag. It looks cool, but it's still not the effect that I want it to be. It's really not. And so what I actually need to do is I need to write a program to do this because I don't have a way of doing this in Inkscape. What I'm trying to envision is actually really hard to do without computer programming. Now, I need to come up with the title for my project. I'm going to be creating a new project. And because I want to be able to see the entire workspace, what I'm thinking is I'm going to take, let's take, well, first of all, let me choose my title. I have an idea because it's going to involve a checkerboard. It's totally going to involve a checkerboard. Um, so let me see. Now, let me see here. I know what a checkmate is, so define checkmate. Yes, a check from which a king cannot escape. Because I am a chess player, so checkmate. What does it mean when someone says checkmate? Checkmate is a chess move that makes it impossible for your opponent to win. Yep. Yeah, so checkmate is used in other contexts, but it's really from a game of chess. But what about checkbait? Okay, notice that when I search for checkbait, it does, including results for define clickbait. Search only for define checkbait. Well, here's the thing. Let's just look checkbait. Let's see, checkbait. Our Chrome section finds offensive and disturbing viral content on any YouTube and warns the user to avoid the videos. Huh. Interesting. Checkbait. Chess of life. Let's see here. Ooh. So, apparently, and then that's about fishing or hunting. See, here's the thing is, people are talking about checkmates and stuff. But the term checkbait, um, let's see what this is about here. Okay. Checkmate to clickbait. Okay. Ever wondered how videos with, let's see here. Ever wondered how videos with poor quality and content make it to the top of YouTube recommendation lists? Ever surprised why a few videos always spoil your mood whenever you visit YouTube? Ever puzzled by how people become very famous on social media despite any good skill? Well, the culprit is clickbait journalism. Let's see here. Okay. Interesting. Hmm. Interesting. It's software to get rid of low quality clickbait. So, obviously, let's go back to the previous results. So, clickbait, because I know what clickbait is, but in case you don't know what clickbait is, the Wikipedia is Wikipedia is always there to save the day when it comes to explaining things. Let's make the text bigger here. Okay, clickbait is a text or thumbnail link that is designed to attract attention and to entice users to follow, click, and link and read, view, or listen to the linked piece of online content, being typically deceptive, sensationalized, or otherwise misleading. A teaser aims to exploit the curiosity gap, providing just enough information to make readers of news websites curious, but not enough to satisfy their curiosity without clicking through the linked content. Clickbait headlines often add an element of dishonesty, using enticements that do not accurately reflect the content being delivered. The bait suffix makes an analogy with fishing, where a hook is disguised by an enticement bait, presenting the impression to the fish that it is a desirable thing to swallow. Yeah. Before the internet, a marketing practice known as bait and switch used similar dishonest methods to hook customers. In extreme degree, like bait and switch, clickbait is a form of fraud. Click fraud, however, is a separate form of online misrepresentation, which uses a more extreme disconnect between that which is being presented in the front side of the link versus what is on the click through side of the link. Also, yeah. So basically you get the idea that clickbait is where you see a thumbnail or you see a headline of like a news article, and the title is misleading because it says something that's not factually true, and that you'll know if you actually read the entire article. Or the video thumbnail will have something designed to catch people's attention, usually somebody naked or something like that, just to get you to watch the video. And then they're hoping that even though the videos aren't related, that you will stay and listen to the video and whatever. So people on the internet are familiar with clickbait. However, I actually am thinking checkbait is an idea, because it's sort of like yeah. Let's see. Let's just do checkbait. Yeah. Let's see here. I'm not going to look at the Shutterstock because I don't know what I'm going to see. And see, bait is usually used when somebody is hunting or fishing, which of course, as a vegan, I'm against hunting and fishing. But checkbait is actually a very interesting title, because it sounds like checkmate, but in a way it's clickbait, because but it's the honest type. So okay, if I succeed in my project, it will be very interesting to see what the result of this is. Um, I don't really know. And in fact, I may think of a better title for this in the future. But for now, I'm going to go with Checkbait. That's what I'm going to go because it's clever. It sounds clever. I made up a. Let's see here. Yeah, I made up a term. So we're going to take the progress flag. We're totally going to take both sizes of the progress flag. Actually, let's go. Okay, I need to go back to my SDL projects, and we're going to make sure that in that both sizes here, we want both sizes of that So it has both of those sizes plus the original image, so that can be freely interchanged. So here's the thing. This is nice because, let's see, it doesn't contain render, but it contains surface. That's exactly what I need. I totally need this. Okay, so what I need to do is I need to make a fork of this project. Here's what we're going to do. It's good. This isn't going to be a chess game, but it's going to use the checkerboard, chessboard, checkerboard, same exact thing. But we're going to call it Checkbait. So what I'm going to do now is I'm going to simplify things. I'm going to copy and paste, Control C, Control V, and it's going to be SDL is always the prefix, of course, because it's an SDL project. Some of my older ones don't have that, but whatever. I forgot what they even are. Okay, so let's see here. Okay, SDL. Let's see here. I could include Chase as part of the title, but that's more something I do for games and just small demo projects. We're going to call this SDL Check Bait. Okay, so we have all those files copied. Actually, now wait, okay, is checkbait, should it be one word or two words? So clickbait is they're put together as one word. There's not a space in clickbait. And since there's not a space in clickbait, there's not going to be a space in checkbait. So that's what we're going to do. So here, we've made a fork of that project. We've totally made a fork of it. So now, what we're going to do here is we're going to simplify the code, because in this fork project, I don't need all three of these. In the original, it's great because it uses the command line arguments. It's really awesome. That's awesome. That's totally awesome. But in this one, we're going to well, I can leave most of it the same. Okay, let me go back to where I was at. So SDL check. Okay, where is it? Okay, SDL checkbait. So what we're going to do now is I'm going to delete this one. We're going to simplify the code a little bit. We're not necessarily going to need this batch file. It's in the original project. And here, yeah, we're still going to keep this file here. We're going to keep this file because we're gonna still want to display text. But let's do things a little bit differently here. So here, it's nice, but I don't want to have to enter a command line argument every time. I really don't. It's nice. It's a nice example, but we're going to modify several things about this. So let's see here. Let's see, is everything going on well with the stream? Been going for over an hour. I've been explaining a lot of my projects here. So yeah, so we do. Okay, so here's what we're actually going to do. I'm going to modify the source. I'm not going to um, let's see here. First, the description. Okay, SDL Checkbait. Okay. Then it adds a checkerboard. I'll write more on the description later. So here's what we're going to do. I need to simplify this. I really need to simplify it because I don't want it to be too complicated. Or do I need to simplify it? Yeah, let's see here. I mean, it's not bad, but what we want to do is, okay, so, because I want to keep the source small enough that it's manageable. Let's see here. Let's look how many times argc happens here. So yeah, so then there's that. Yeah, so the arguments are used multiple times. But yeah, this is strange. So here's what we're actually going to do. We're going to, I want to keep this simple, small and simple. So in the original, it was great that I was using command line arguments. It was a general image viewer. But in this case, what we're going to be doing is we're going to remove the command line arguments. We're gonna eliminate that. It's still in the original project. Let's see here. Yeah, okay, yeah. Okay, that simply prints the arguments. Okay. And then what we're going to do is we're going to let's see here. So here should be the end. Okay, so actually I need syntax highlighting for this portion. I'm going to open this in Visual Studio Code because it has nice syntax highlighting. And okay, so here's what we go. I'm going to ignore the errors. The point here is we're going to, so there is on line 38, there's the opening brace. But here is the closing brace. So what we're going to do here, no, I don't want to download an update. Let's see here. Let's see here. And then we're regardless, either way. Okay. Okay, I need to find a way to do this right. because we don't want it to. Okay, so let's see here. Okay, so here's what we're going to do. This section is, instead of having this brace, we're going to remove this. We're going to remove this if statement entirely. We're going to remove that, and we're going to remove this. We're going to remove all of that. Okay. Because it's not going to be if statement. It's not even going to check the command line arguments, because I need the code to be small and manageable. Okay, also without a previous if. Okay. So we need to correct this error. Okay, yeah, let's see here. So, but we're not going to, this is where it creates a blank image. Okay, so okay, here's what we're going to do. So this is what it does if it fails to load an image. Okay, so if it fails to load an image, okay, no bitmap, because we're not going to have arguments in the language here. Okay, no bitmap was loaded. Okay. So, so here's what we're going to do. We're going to combine this. So it tries to, okay, so the program will end here. Okay, so here's what we're going to do. Okay, I'm thinking how to do this. So, all right, so here's what we're actually going to do. So what we're going to do here is we're going to have this here. It's going to do that. But if we're going to do another state. We're going to do if the bitmap temp is, okay, if it's not equal to null. I hate the way it tries to autocomplete things. Yeah, so if the bitmap temp is not equal to null, then it's going to convert that surface to the new bitmap and then free the temp bitmap. So let's see here. I'm just kind of fixing it. Opening file name. All right. Okay, yes, see here. So here's the thing. We technically don't need this here anymore, because this is what happens if it's not no. Okay, so then in this case we don't need this because it will automatically display this. If it's not null, it will convert the format to that. So we don't need this because we don't need the program to return. Interesting. That's very interesting, in fact. We don't actually need the program to end at this point. We don't even need it. So here's what we're going to do. We're going to delete this portion, simplify this. Okay, Now it's working as expected. So enter file as command line. Okay. Now I'm going to change this text probably. I'm probably going to change this text um, because it's not going to be applicable anymore. But here's what we're going to do. What we're going to do here is we're going to, yeah, so here we're going to use a hard-coded bitmap file. So let's make sure that we use the correct file name. We're going to load the file name from this hard-coded string. So let's try 1920 by 1080. That should be the correct file name. And you can tell because here is this. So let's try this. Let's try loading that image. Because we're just going to go with the base case. That's what we're going to do now. Hey, it works. It works. It actually works. It loads that image, and of course it looks funny. It totally looks funny, of course. Hmm. Yeah, so let's see here. So it works, but we want to actually use the smaller image. So 720 for the height and 1280 for that. Okay. And you'll see that it displays the bitmap width and height. It did that. Okay. So let's try here. So now, here's the thing, is that it's displaying this text, but why is it displaying this text? I don't actually want it to display this text right now. Okay, so here's what we're actually going to do. So, let's see here. Okay, first of all, let's check something. Let's put an extra character in the file name and see how it behaves. Okay, yeah, enter file as command line to display it. Yeah. So, yeah, it displays that blank page. That's the correct thing. Okay, that's nice. But when it does load the file, then let's see what it has. Okay. But we don't want it to do that. We don't want it to do that right now. Let's go here. So it blitzed that bitmap that's been loaded. It's been loaded into a temporary one. It's been converted into the right format. And this one, yeah, so this part here, yeah, okay, that works. So then, this is what it does, is it will return if something's wrong. Like, let's say we try to make an extremely long image. Oh, right. That doesn't even apply because the file exists. Well, either way, yeah. Okay, let me try something here. Let's say that we added that there's an extra character in here. So then it does a thing. Yeah, window could not be created because notice the width is far too big, window is too large, so it failed. It totally failed. But if we go back to here, and we load that image, then it works. It just works. But yeah, we're just gonna go back and make this correct because getting the progress flag loaded is part of the battle. I wouldn't say it's half the battle, more like a quarter of the whole battle. Okay, so it blitz it to the surface. Surface is the Okay, the actual stream. Now this one, notice that it does this if arg count equals 1. Ah, we don't actually, we actually don't need any of this here. We actually don't really even need this. It's nice only for the fact that it shows, yes, this completely shows what it looks like when text is drawn. Text is totally drawn onto the image here. And we're probably going to be using some of this. Actually, let's see here. Now that one, what I like about, see, it has one that has the black background to the white text. That's nice, but we're not actually going to be using those. We're not going to be using those. We're going to be using, yeah, we're going to, oh, this shows the, oh yeah, okay, yeah. We're not, because we don't want that extra background anyway. So let's remove these function calls there. Okay. Okay, so then it just displays that text, which is totally acceptable. That's totally acceptable. Okay. Yeah, I'm just making sure it works. Enter. And you can't really see it, obviously, because it kind of conflicts. But it may be relevant in the future. It might be. It just looks particularly conflicting. But what we're actually going to do is I'm going to comment out this section. We're not going to be displaying. Okay, here's what I hate about Visual Studio Code. When I try to start a comment, it creates a whole new comment, and I don't want that. I want a multi-line comment here. That's what I want. And Visual Studio Code screws me up. And that's why I use it for syntax highlighting, but not much else. It tries to take control and not do the code the way I want. So now we just have a basic thing, chassis progress flag. See, so it loads that. Okay, it works. It's flawless. The program works. The program starts and it loads that exact image file. It totally loads that image file. Okay, that's exactly what it needs to do. Now, here's what we need to do. We need to draw a checkerboard on it. At first, we're just going to draw a basic checkerboard. That's what we're going to do. Let me, let's see here. How's my stream going? Nope, nobody's watching my stream. Okay. Let's close Visual Studio Code because this program drives me crazy. But anyway, I just installed it because I was experimenting with it. But I will use it for text highlighting occasionally. So now okay, let me look at the chased font. Now this one that draws a specific color, this uses direct pixel access. And this is from the other project. And it works. It really works well. So yeah, okay. Now here's an idea. This is actually okay. This is a funny idea. I'm gonna show a funny idea just for the sake of example. I'm going to do a little modification here. I've commented out that code that was part of this one thing here. But we're gonna do chase font draw scale color, and instead of just loading the text, we're just going to have this be completely separate. We're going to have this separate here. I'm just going to make a statement here, a hard-coded string. So we're just going to do the string chastity. We're going to do this. Oh wait, that's the wrong window. That's totally the wrong window. Okay, back to here. You can see it because it partially covers that it partially covers that um, purple thing there. So otherwise it's hard to see. But the text is there. It's very hard to see. But here's what we're going to actually do. I'm going to make a copy. I'm going to make a copy of this. Yeah, okay, this is going to be really, really funny. See, this code works well. But actually, before I do a copy, let's do something. We're going to, because it's actually now this one, wait, color. Yeah, it gets the, okay, oh yeah, so this one actually it actually does fill a rectangle to a destination based on the source, but it doesn't actually do each pixel individually. Well, I'm going to leave this alone for now. I'm going to totally leave that part alone for now. Because we may be doing something with the text later. Just for the sake of it, we probably will be. But I'm going to remove this text. We're not going to have any text here. Okay, so now back to just a plain old progress flag image. But what I need is, okay, notice how it says STL chase font surface. Okay, yeah, I'm going to, first of all, I'm going to go, if we go to my Tetris game, notice how in this STL Chase Tris 2, now this Tetris game, it uses the renderer. It totally uses the renderer here. And you can tell by looking at the source code. Notice that it says texture with the chase font. You can tell by looking here. It uses a certain structure for the font, similar, but it uses a texture instead of a surface. And you can tell because when it draws with the render, yeah, okay, texture from surface renderer, okay. Yeah, SDL render copy. That's what it does. Instead of blitz surface, use render copy. Where it shows with the original blitz surface from the original, the used surface, because the code is mostly the same. But my original Chase Tris SDL, which still exists, and it's right here. We're going to go here. We're going to notice this one. It looks different. This one has not been updated. This one is a complete implementation of Chase Tris, my Tetris game, and it is a complete Tetris game, but the graphics look a little bit different. It doesn't have all of the features of the new one. The new one operates faster, but this one is kept around for legacy reasons, for very specific reasons here, actually. Okay, this is a very funny pattern I'm making. Because this Tetris game, it does, now this one, SDL Chase font, it's not named surface, but it is basically the same stuff. It uses surfaces for all of the font handling. But not only that, it does it for all of the rectangle handling. So in the actual game itself, we're going to do, let's do it for a surface. Yeah, so the welcome screen, it fills the whole surface with null, the entire thing with black. That's what it does. Update Windows Surface is used extensively. That's used throughout the whole game. So this version uses the surface, and that's why I can never delete this one. I can't delete this one because I always need to remember how to do things the old way. But what I'm actually going to do now is, I think I have enough data even within my existing project. I'll keep the other thing open just in case. But let's see here. Surface. Okay, convert surface format, free surface. SDL fill rect. Yeah, okay, let's see. Fill, STL fill rect. Okay, yeah, that fills that bitmap with the rectangle. So that's an important function that I need to know. So here's what I need to do. We are in our um, our checkbait project, and actually, let me see here. 5.9 kilobytes, 06/06/2023. And over here, it was Chase font. Oh, that's even. I mean, I'm not going to mess with it if it works, but the file is probably the same. Oh wait, 6.9 kilobytes versus 5.9 kilobytes. Well, what is contained in this here that's not contained in the original? Um, oh, I see this one. Oh, yes. Um, Chase font drawstring scaled color, because this one was the drawstring scaled, and this one, this one doesn't even use the blitting function. It does things a very, very different way. In fact, that's why I never copied this file over. I'm going to keep this here because this is very important to see that it actually works. So that is super important. Yeah, DSP. Okay, I see how it works. Yeah, that's what. Okay, I see how it's gonna work. Oh yeah, this is gonna be harder than I thought because it's just yeah, but it does draw a square of width equal to scale because yeah. Oh yeah. Oh, it's crazy. It'll probably become easier once I actually start working on it, but this is just sort of a reference for how complicated direct pixel access can actually get. So what I'm going to do now is from we're going to go to another project of mine. We're going to go to Chase Chess because here in the source, you'll notice that I had an entire source file. This is SDL Chase checkerboard. This file is just my own personal method of drawing a checkerboard in SDL2 using a renderer. Now this uses the renderer. It does everything with the renderer. This is the render method, SDL Chase checkerboard. But what I'm going to do here is I'm going to copy. Well, first let me take a look at the file again. Initialize the checkerboard where it begins and where it ends. Yeah, totally do that. Yeah, this was a very optimized one. Yeah, I only include the most optimized method. What we're going to do here, Chase checkerboard, we're going to copy that checkerboard file here. And okay, we're going to, here is the main, the main file here, and we are going to need to include that image. I mean that source file. Let's see how it was included here. Because in my chess game project, I had included stdio. I didn't include all the things that were included here necessarily. But yeah, important stuff. This is a smaller project, so we're going to include SDL Chase checkerboard. This one is what we're going to do. Now, it's very important to understand that you can't. This source file must be included after width and height. You have to include. You have to like for example, let's say that we try to include this file here. Let's try including it before defining those global variables. Let's try this. First of all, the file name is, yeah, okay. First of all, yeah, it's correct. There are some errors, but I also want to update the file name. So SDL Chase checkerboard surface. So now, yeah, there is no such file with that file name. We're going to rename this file. Wait, yeah, let's I don't want to get confused here. We're going to rename this one. This is the Checkbait folder. Checkerboard surface. So now that we've corrected the file name to be notice that it has errors. Width undeclared, rect undeclared, renderer undeclared. Well, that's because these global variables need to be defined. My programs always use a rect for rectangle structures, width and height, and uses render, but I'm going to correct all this. So instead, what we're going to do, we're going to include this file, but we're going to include it after all of the SDL events are included. So it's going to be included before SDL chase checkerboard. Okay. Okay, so now here's what we're going to do. So now, okay, let me clear. Ooh, let's see, error rect undeclared. Ooh, first using this function. We need to have a global rect variable in chased checker. Yeah. So here's what we're actually going to do. Let me open the recent document. Open recent. Let's see, which one was this? SDL rect. We're going to have a global one. This is from the chess game. I opened the recent document, and we're going to make sure that, okay, right after the event variable is the SDL rect structure, global variable. So we're going to put this right here because it's essential. And now let's try redoing it. Okay, render undeclared. Notice now render is the only thing it's complaining about. It's totally, yeah. So because all the rest of the code is the same, but what we actually need to do was close this document. Let's look at that line. Line 50 of chase checkerboard surface.h. Actually, just look at that again. Because that's what it does. It shows that error right on that line. SDL render fill rect. Okay, so here's what we're actually going to do. We're going to okay, here it is. So here is where it is. SDL render fill rect. So if the index is 1, it's going to try to draw a rectangle. Now, first of all, let's comment out that line. Okay, so it doesn't do anything, but at least there's no error. So what we need to do now, we need to do something very careful. See, in the renderer example, in the original render example, I'm going to go back to chase chess. You're going to see that the you're going to see that the color is the render draw color is set before the chase checker thing. But in this case, here's what we actually need to do. We need to find a way to fill it with a certain color. Well, I have an idea of how I'm going to do this. So, first of all, we're going to go to fill rect. We're going to do fill rect. Let's try something. And we're going to replace, because the rectangle has been set up. Everything, but instead of the render fill rect, we're going to do SDL fill rect. Now, notice it goes to the bitmap instead. Right. That's not really necessarily what we will. Although of course it can be made to work. It totally can. Um, but instead, we need to make sure that we actually call the function. We need to make sure this function is called. So chase checker. Okay, yeah. We need to initialize things. So after it loads the image, it loads the bitmap into the surface. Then before we're going to try this. I'm going to try something here. Just going to see if it works. Because we're going to be updating the surface, the global surface variable. So we're going to fill the rectangle. Okay. Surface. Programming is complicated. Okay. Very interesting. But it doesn't seem like it does anything. But we also have not properly initialized things. But yeah, so we're filling that surface with that. But we need to initialize the checkerboard. So first we need to initialize the state of the checkerboard because the checkerboard structure exists. It's called main check. So yeah, main check, the global structure variable that controls the checkerboard. But we haven't initialized the values. So we're going to have init checkerboard. Set up our initial state. Okay. Let's try this. We have to make sure we set up. So initialize the checkerboard structure, the global one. And then, ooh, how interesting. It's actually very interesting. Huh. That's very strange. Yeah, something is not quite working the way I wanted it to work. Hmm. And also, because we're just doing it with this certain color, let's try. Oh, that's right. Of course. I feel like such an idiot. Of course it draws the entire screen with that color. Yeah, okay. Let's Yeah, of course it does. Because notice I was supposed to use the address, the pointer of the rectangle. We're going to be use the rectangle, not because null fills the entire surface with the color. Okay. Hey, it works. Okay, now we've got it working. Now it works. So you see how we have a green checkerboard pattern on top of the progress flag. And of course, we can change the color by changing the function itself. So let's try this. So now it's black. That's not bad. It's black. It's cool. It's very, very cool. So that's nice and everything. And that looks a lot like that Inkscape image I had designed. All right. That looks very good. That looks good. but I'm going to be modifying this. We want to do an XOR checkerboard. We totally want to do this, but I've gotten this far. But how do we, okay, so for example, what we may want to do is we may want to simply, hey, I like that look. That looks very cool. Okay, what we're going to do is we're going to, yeah, we need to add another variable because when we look at Chase Chess and we look at this, the checkerboard structure, it has its beginning and top left and its ending location, the size of each square of the checkerboard. It has all that, but it doesn't have a color. It doesn't really have a color exactly. So, here's what we actually need to do. For this one, we're not gonna update the original, but for this one, we need to update the checkerboard structure. So, initialize checkerboard. So, well, first of all, we need those are the int. We're gonna make a new int. So int, okay, int rect. Okay, we'll just do int rect color. That's what we'll do, int rect color. And then we're going to set here in this structure, we're going to do rect, just like we had rect size, we have rect color. So rect color, okay, yeah, so it's main check dot rect color, that's the element of that structure, equals OF. Okay, let's make it magenta. Let's make the color, the initial color, we're going to make it magenta. Okay, but we need to update this source too. So what we're going to do here, main check dot rect color is going to be what we do here. Now it will, whatever the color variable is set to be. Okay, now that, hey, that looks cool. That looks actually very cool. I like that look. So, but we're not going to have that be the default color. Instead, let's have white be the default color. We're going to have white be the default color. Okay. And then, for instance, if we want to change, anytime we can change the global variable here to, yeah, we're going to change it. Now notice that if I put this here, let's say we wanted to make it blue, if we call it before the initial checkerboard, it's not going to work because that function is going to change it to white. But if we call the init function and then we update the main check color to blue before calling it, then we've made it blue. So it's actually really, really cool. It's actually very cool. I have made a lot of progress. I don't know if I'll be able to do the whole thing tonight, but I've made tremendous progress here because I have the image loaded. I have a checkerboard drawn on top of it. Let's comment this out. I've made so much progress in this new project. That I need to make serious backup. Yeah, totally going to make a backup of what I've done so far here. I'm probably going to end this, yeah, probably going to end this stream, but I've gotten this far. I may continue this in a part 2. But now I have my checkerboard and it works with SDL surfaces. I've gone on for a while here, almost 2 hours, but I do need to end this stream. But I'm going to check do I have any comments? Nope, I don't. Oh well, I'll probably download this video and upload it to YouTube eventually. But I've made some amazing progress and explained a lot of process of what I do with my programming. Good night.